Hello and welcome to DC analysis of a MOSFET video tutorial. This tutorial describes the MOSFET model in PSpice and how they are used in DC analysis of a MOSFET circuits. The focus will be on the enhancement type and MOS devices. There are a number of models that can be used to describe the physical characteristics of a MOSFET with a PSpice. These different models are specified with a level number. In this tutorial we will use level 1 model, which is the simplest and the default value. In the level 1 model we can specify values of Vt as VTO, K'N as Kp, length L, and width W, along with other parameters that are described in a PSpice reference manual. Let's build the following circuit. We will use mBreak N3 model for our NMOS device. We will also be using VSRC current voltage sources in order to simulate our sweep analysis. And let's put the ground and wire our circuit. Now let's do right click and go to edit PSpice model. Alright, and then in parentheses our threshold voltage, or VTO, will be equal to 1. Our K'N as Kp is going to be equals to 5e to negative 5, and our length will be 1 micro and width will be 10 micro. Let's save and close the window. Now let's go ahead and do new simulation or edit simulation profile, and we will choose the simulation type to be a DC sweep, and our primary sweep will be for the voltage source V2, and this will be a linear sweep from starting value of 0 to end value of 5 with an increment of 0.1. On our secondary sweep we will be sweeping voltage source V1, and our start value sweep will be also linear, and the start value will be 0, the end value will be 5, and the increment will be 1. Okay, let's hit apply and OK, and let's put our current probe at the pin of our transistor. Now let's run the simulation. And you should see the following curves, and from this set of curves we can make the following conclusions. Each curve begin to flatten out at a different value of VDC. In each case that occurs of VDC equals to VGS minus VT. The current at the flat portion of each curve, the saturation region, corresponds to the equation ID equals to Kn VGS minus VT squared. Now let's modify our circuit, and instead of V2 voltage source we will put a DC voltage source. And the value will be 10 volts. Let's edit our simulation profile. We will uncheck the secondary sweep and we'll do only the primary sweep. And our primary source is V1. Our sweep will be linear with a start value of 0 and value of 10 with an increment of 0.1. Hit apply and OK. And let's run the simulation. Okay, let's just change our y-axis so we have a little better view of this curve. And we'll change it to 20 milliamps. And this curve is ID versus VGS relationship in the saturation. Now let's build a new circuit. Please take a few moments to build this circuit, and you can pause the video if necessary. Our voltage value will be 5 volts, and V1 voltage value will be actually -5 because the polarity is reversed. Our resistor value will be 2K, 60K, $1K, and a 40K. Okay, let's modify our PSpice model, and now we want to have our Kn to be 0.05 milliamps per volt squared, so our K prime N will be or Kp will be 1 to 0.1 to the negative e to the -3. So let's save changes and close the window. Now let's edit our simulation profile, and we'll just choose bias point analysis, and make sure that you the include detailed bias point information is selected. The check mark is there. So let's go ahead, apply, and hit OK. And when we run the simulation and make sure the simulation complete. Now let's go ahead and take a look at the voltages at the nodes, currents, and the power dissipated or delivered. And now we can also go to view an output file and view the output file actually right over here. So we can go ahead and scroll down to see the operating point information provided as well. So it's right over here. So can we see VGS, VDS, and all the information we need. Well, this concludes our tutorial. Thank you so much for your attention.